Welcome to the course on microservices with Spring Boot and Spring Cloud. So first things first, what we are going to build as a part of this application. So we are going to build 7 different modules of microservices, which are as follows: limits service, Spring Cloud config server, currency exchange service, Netflix Eureka naming server, Netflix Zuul gateway server, Zipkin's distributed tracing server. So we will be building all these microservices from the scratch. And in the process of building these applications, you will be coming across different concepts of microservices and Spring Boot, Spring Cloud, and many other technologies. And as a part of this video, we will be discussing on theoretical parts like what are microservices, what are the challenges associated with the microservices, and we will be discussing about all the fancy terms that are used in the IT industry: the Zuul server, load balancer, fault tolerance, centralized logging, and all. So the most important thing of any project is the skills that you are going to build as a part of that project. The skills are the only things that matter. So as a part of this project, you will be learning microservices, Spring Boot, Spring Cloud, RESTful web services, ribbon load balancing, Histrix, Zipkin's distributed tracing server, Netflix API gateway. So for getting started with the project, you will need only few tools, that is Spring Tool Suite or Eclipse or IntelliJ gateways. We will be installing it when we are in the practical session. The Postman is a very small tool. You can use a Google Chrome extension or you can download it. In the JDK, GRE 1.8 or above we will need. So after taking this course, I assure you that you will be able to answer most complex interview questions on microservices and Spring Boot. So the prerequisite for taking this course is that you should have knowledge of Java, a little bit of understanding of Spring Boot, RESTful web services will work good for this project. And as I mentioned earlier, that this project is designed for beginners and people who are having an intermediate level of experience with Java and microservices. So how you can take the course, that also I have mentioned earlier. You need to have a JDK or GRE installed 1.8 or above, Spring Tool Suite or Eclipse or IntelliJ. So how you have to take this course? When I will be going through the practical sessions, I will be explaining my code theoretically, as well as when I'm writing the code, you need to pause your video and write your code yourself, and then you can come back and compare your code with mine code. So about the author, this is me. I'm an IT professional with 6 years of experience as of 2020, and I work as a full stack Java developer in Accenture. I have worked on so many cloud-based projects and I have been able to solve most critical problems which are faced in day-to-day projects. So for now, you should know only this much about me. Let's move to our theoretical session. So what is a microservice? There are so many authors who have given different explanation about microservices, but all the explanations means the same. According to Martin Flower, microservice architectural style is an approach to developing a single application as a suite of small applications, each running in its own process and communicating with lightweight mechanism. We will be showing this to you in a practical sessions, like how microservices communicate with each other. So there are definitions by Gartner. There are other definitions as well, you can go through it. But what I want you to know that the microservices are small applications which are connected with each other with a lightweight mechanism, and it has an input and it has an output. So every small unit of microservices will be having input and it will be having output, and this all will be connected with each other. And if I remove the connection between this microservice and this microservice should be able to run independently. So that's the definition of microservice. Let's move to next slide. So let's understand the traditional approach. First of all, you should know who is this guy. This guy is your God. So the God comes in and gives you so many requirements. As you know, a project will be having so many requirements, and the God will keep on giving you requirements at every phase of your development. So you got the requirement, you start building up your project, and you started with building the main application. God kept on coming and kept on giving you requirements after requirements, and you added different modules to the requirement, keep on adding, and at the end of it, you will be coming up with a big monolithic application which will be very hard to maintain. And at this point of time, if God comes in again and gives you one more requirement, there are some more changes in the business, make the changes accordingly. When he gives us requirement at this point of time, it is very hard to go back and add a new module to it and test the application and say that okay boss, I am done with it and our application will be working fine after making this change. So every time that takes up effort for developing, for integrating and for testing. So it's a very traditional approach that we used to follow. Let's see at microservice approach now. In the microservice approach, what we do, the God came up with the requirement and we start building different microservice. This microservice 1, 2, and each team member is assigned one microservice. So one team member is working on one microservice. After completion of 5 microservices, these applications are integrated with each other and producing a common output. Let's say that microservice 4 is a payment application and this is using Just Pay. Now after integrating all the code, suppose the God comes in again and says that I want to change the payment method. We are not dealing with Just Pay now, we are dealing with PayPal. So what you do at this point of time, you just remove this microservice 4, you build a different microservice again which is for payment related to PayPal, and you just integrate this application with this one. And after that you need to test the application that your integration is successful and whatever the expected result is there, that we are getting it from here. So it's a very modern approach and microservice approach. Now let's move to the challenges associated with the microservices. Let's see them one by one. The first challenge is the bounded context. What do I mean by this bounded context? Let's see this with a real-time example. I was working in a project and at the beginning of the project there were 16 modules that the client has given and we started working upon each of the microservices. So after building these 16 microservices, when we went on to integrate each other, we found lots of gap into it. So we had to add on some more microservices to it. And at the end of 2 to 3 months, we ended up in totally 32 microservices. So from 16 to 32, we started with the 16 microservices on day 0 and in 4 months we reached up to 32 microservices. So what I mean to say is that at the beginning of any microservice project, you cannot define like we have to build only 5 modules and our work is done. No. So we can say that it is an evolving process which you will figure out once you start your development. Let's move to the next challenge that is associated with the microservice, the configuration management. What I mean by that configuration management, that let's say we have 3 microservices, 1, 2 and 3, and each microservice is having different instances running. And let's say that this is our L1 environment. This is L1 environment, this is L2 environment, and this is your prod environment. Some of the projects are having even 5 environments. So for each of these environments, we need to have configuration, say our URL configuration, our database configuration. When you are working in a real-time project, there are so many external configurations that we need to maintain in a file, and these files are based upon the environment. We will be talking about all these things in details when we are into our practical sessions. So it is very challenging task to maintain these configurations, and we will deal with all of this when we are into the practical sessions. The third challenge associated with the microservices is dynamic scale up and scale down. What is that? Let us suppose that we have 3 microservices and it's an Amazon application. Microservice 1 is having 2 instances running currently. Let's say this is a normal day and we have a Christmas day, and let's say it's a Diwali. So what I mean to say here is that microservice 1 today, in the normal days there are 2 instances. What happens when Christmas comes in, the load on the Amazon will increase and you need to scale this up. That means that from 2 you need to have 4 instances or 5 instances of this application running. The more amount of load, the more amount of instances you will be having, and you will need to scale all these microservices application in your peak days. Same applies for Christmas, same applies for Diwali, and again in the normal day you need to scale it down. This type of dynamic scale up and scale down we need to implement in our project. And how we can achieve that? by using dynamic load balancer, we can overcome this problem. This will save you lots of money. Now the next challenge with the microservice application is the visibility. What I mean by that, suppose you are having 5 microservices application talking to each other and some trouble happened at microservice 3. Let's say an exception occurred. How you will identify where the problem is, where the exception has occurred? You will not go to each of the microservices individually to check where the exception has occurred. So we need to have something called centralized logging system. We say Splunk or Kibana, where we will be configuring our microservices application so that we can get exactly where our bug is, and monitoring is required for this kind of projects. The next challenge with the microservice application is a stack of card. So what I mean by the stack of card is this. Suppose you are having this stack of card. What happens when I remove this card, or what happens when I remove this card? Your all of the cards will fall down. This is the same thing that happens with the microservice application. If one of the microservice application goes down, your all of the microservice application will go down. So fault tolerance comes into picture. We will see about all of this in the practical sessions. This was the last slide. From the next video onwards, we will be moving directly with our practical sessions. And in the end, I just want to make one appeal to you guys that the content which I have created takes lots of time and effort to create it. And this kind of content you will not be getting on any platforms for free. And you are getting this on YouTube for free. So if you really like my videos, click on the like button and subscribe to the channel. And if you are facing any kind of challenges while taking this course, you can directly write it in the comment section and do provide your valuable feedback. Thank you for watching and see you in the practical sessions. Hello and welcome everyone. From this video, we'll be starting our practical sessions. So let's get started. We will be building 7 different modules of microservices. These are listed here: limit service, Spring Cloud Config Server, Currency Exchange Service, Currency Conversion Service, Netflix Eureka Naming Server, Netflix Zuul Gateway Server, and Zipkin's Distributed Tracing Server. So we will be making all these 7 different microservices, and we will be assigning the port to each of the microservices. So we have written all the ports in a separate place in a GitHub so that it will be easier for us to maintain. And this link I will be providing in the description. You can take it from there. We will also be adding endpoints associated with each of the microservices just below this one. You can get all the endpoints from there, or you can create your own endpoints. I will just be keeping it here so that it will be easier for me to maintain in future. Now let's move on to the next step. As I told in the beginning, we'll be developing everything from the scratch. So I will not even skip one step. So let's start it from the beginning. First of all, you will be needing a Spring tool suite, that is a IDE for building the Spring Boot applications or microservices applications. If you are having Eclipse or NetBeans, you can very well use that. Now this is Spring tool suite 4 that I'm using. I'm also keeping the theme to black. It will not be having much brightness. I will increase the font size as well. So let's go on to create our first application. First, we will be creating limit service, that is our first microservice, and it's nothing but a Spring Boot application. So let's go on and create our first microservice. Click on New, Spring Starter Project, and you need to have a working internet connection. Give the name of the project. Now the artifact will be automatically coming here. The group name, I will keep it com.technotab, my channel name. Then I will be keeping the package name in this format, limits. Now click on next. What all things we'll be needing here? We'll need a web. So this is Spring Web. We'll take DevTools. For now, let's take these 2 services only. We will create the project. Click on next and click on finish. So when you click on finish, it will show the progress in the progress bar. If you are downloading this version of Spring for the first time, then it will take some time to download. So the application is fully downloaded and you can see a boot and a DevTools extension. This DevTools extension we have added because whenever we are making any changes in our code, we don't have to manually go and restart the server every time. It will pick up the changes and it will restart the server. So this is the folder structure. It has got a src main Java folder that is having our application and the resources folder, test folder, the JRE libraries, Maven dependencies we have got here, and the POM file. Let's see the POM file once. I will increase the font a bit. In the POM file, we have got a parent tag that is having all the information about our Spring Boot versions. Spring Boot starter parent, then the version is 2.2.2. The name of the project that we created, group ID, artifact ID, and this description. You can change that later. The Java version is 1.8. Then the dependency that we added is a Spring Web Starter and the DevTools. And this dependency, Spring Boot Starter test, is automatically added. And that's all about POM XML. Now we have got the project. Let's make sure that our project is running fine. So the Spring Boot application comes with embedded Tomcat server. So you don't have to externally download any Tomcat server. You just need to go to run as and start it as a Spring Boot application. You can see in the log here, Tomcat started on port 8080. That is the default port, and our application is started. You can see the red button here, and when you go to this boot dashboard, you can also see it here as well. See this up arrow mark, that means that it is up, and on the port it is showing here. So our application is up. Now let's move on to next step. Now let's look at something very important, managing the configurations. There will be multiple microservices talking with each other, and there will also be different environments related to each of these microservices, like a development environment or QA or a stage environment or production environment. So it becomes a very challenging task to maintain the configuration of all these environments at one place, and that too when we have a different amount of load at different time. Say that currency calculation service is not having load at the current point of time, but at the same time the currency exchange service is having more amount of load. You can see this as during the festival times, Amazon is having more load on its server. So those kind of configurations, it becomes very challenging to maintain. So in that case, Spring Cloud Config Server comes into picture. So this Spring Cloud Config Server will be a common microservice that will be talking with each of our microservice. This Spring Cloud Config Server will be talking to our Git repository, where we will be storing all our environment related configurations at one common place. This will save our most of the time and confusion, and this is the best approach that we use in our real life projects. Now here we have already created the limits service. So our ultimate goal for now is to connect it to the Spring Cloud Config Server and get the values from the Git repository. Let's go ahead and do that. So this is our Spring Boot application. Now let's go to application.properties and give it a name to our application. We have given this name limits service. Now you can give the port number here as per your choice, but what we have done, we have defined that the limit service should be on the port 8080. So I will not change the default port, which is 8080 here. Port number will be same. Now let's go ahead and create a controller class where we'll be storing our limits. Let's name it as limits configuration controller. Click on finish. And we should have kept this in a separate folder. No worries, we'll create one more package and we will name it controller, and we will move this controller to this package. So this is a controller, say REST controller, and we will be creating a method. So what method we will create? We are going to create a maximum and the minimum limit. So let's define a public method first. Public limits configuration return limits. Obviously we don't have the limit configuration as of now. Let's go ahead and create the class limit configuration in the package bean. Let's give two limits, the maximum and the minimum. private int maximum and minimum, and let's create a setters and getters for this class. Go to source and click on generate setters getters, select all and generate. Let's define a private constructor as well, and in the controller class let's give this method some endpoint get mapping, and the endpoint that we are going to expose is limits. So this method will return something. Let's add a return statement and change this return to return the limit configuration, two values, actually new limit configuration with two values, that is maximum and minimum. Let's hard code these values first. 1000 is maximum and 99 is minimum. This limit configuration will be taking these two values, the maximum and the minimum, and the limit configuration we have not generated the construct. Let's go and generate the parameterized constructors. Go to source and generate constructor using field and select maximum and minimum and generate. Now let's go to limit service, save this, and our application is automatically started at port 8080. Now go to browser, Google Chrome or any browser, and hit localhost colon 8080 and this endpoint, hit enter, and you will be getting something like this, the maximum value and the minimum value. So we have hard coded the value and we have got the value on the browser. So we have hard coded the values here. Now let's move to the next step. We will not hard code the values here. We'll set the values in our application.properties. So go to application.properties and here you define your values. How do you define your values? You have to give your application name dot minimum or maximum equals, and the value I'm keeping, let's say minimum is 10 and the maximum value is 1000. Let's save this, and we have kept the values here, but our application is not aware like from where to pick the values. So this is the configuration that we have done. So this configuration we have to enable in our program. Where we can enable this configuration? We can enable this from our limits configuration. So just give this @component and configuration properties, and in this configuration properties you have to mention your application name. Here our application name that we have given here is limits service, so the same name we will be using here. Now you can use any name in application properties, you can use any name, but the same name you have to refer it here in your limits configuration. Let's save this. Now in our controller class, we have to pass this maximum and minimum value. So how we can do that? We have the setters and getters here. We just have to get those two values. So first of all, you have to call this class limits configuration in your controller class. How we can do that? We can just call it as private limits configuration and give it a name and just auto wire it. Now you can use your limits here, limits dot get maximum and limits dot get minimum. Save your application. The changes are picked up and the server gets restarted automatically. Now let's go to our browser and try to refresh it. So now you can see the maximum value is 1000 and the minimum value is 10. That is coming from our application.properties. Minimum 10, maximum 1000. Till now, we are getting the values from application.properties. Now, as we discussed earlier, the limits service is connected with the Spring Cloud config server, and this is the place where all our common configurations will be placed, and that will be talking to Git. So basically, we will be keeping everything in the Git, and this Spring Cloud config server will be picking the values from the Git, and it will be used on demand from these microservices. Let's go ahead and do that. So the next thing we will need is to create another microservice, that is a Spring Cloud config server. So let's go and do that. How we can make this? We have to make another Spring Boot project for that. So let's try a different way of creating a Spring Boot project now. You can also create the project in a different way. To go to Spring Initializer start.spring.io, that's the website, and here you have to select the Maven project and language is Java. The version which we are going to use is 2.2.2. Make sure you are using the same version across your application. So limit service application is having the version 2.2.2.release. We'll be using this version. Now the group ID will be keeping is Techno tab, and the artifact ID is your name of the project, Spring Cloud Config Server, and the other thing is dependencies. So the dependencies that we are going to use is DevTools, and we are also going to use Config Server. Now you can click on Generate Project, so it will download your project. Now go to Downloads. I will cut it from here and keep it in my workspace so that it will be easier for me to find it out or maintain in a one common place. I will extract it here and delete this. Now we have to go and import the project from our STS. Click on File, Import Existing Maven Project. Click on Next and click on Browse and open the project. And click on Select Folder. The POM will automatically come here. Now click on Finish. It will download the project. It will take some time to download it fully. So the download is complete. Now let's have a look of what all things we have got in the POM. It's a good practice to close all the other tabs which are not in use. It will not be confusing for you. Now in the POM, what all things we have got, let's keep it full screen and see. We have got the Spring Boot version 2.2.2.release. This is the first dependency, Spring Cloud Config Server, and the second one here we added is DevTools. This will be by default, and the other things are by default. We'll also get a starting file with the main method. Now let's make the configurations. Open your application.properties. Here we will give our application name. Spring.application.name equals to Spring Cloud Config Server. We have also discussed like we will be giving some particular port to our applications. In this case, we have discussed like we will give a Spring Cloud Config Server port of 8888. So server.port equals. Now you might be thinking, how do I remember all these things? Spring.port or spring.application.name. So these things will come after you have gained some experience. You will be remembering all these things slowly. So don't worry about all that. Now we have created our limit service and we have created our Spring Cloud Config Server. The next step will be to install the Git locally. Let's install the Git locally. So what you have to do, you have to go to browser and search for Git. So Git is a free open source distributed version control system designed to handle everything from a small to very large project with a speed and efficiency. So it is very self-explanatory. We'll go to gitscm.com and here you can get lots of information about Git. Basically, if you don't know even anything about Git, you should only know that this is a version control system where we will be storing all our code. It's like a cloud where you can store all your code. Like how we have here github.com, that is a cloud-based storage to store projects. So gitscm, basically you can create your own Git locally. You don't have to depend on the GitHub. So first of all, we will be creating this locally. So we will be installing it locally here. What you can do, you have to just click on download for Windows. If you are on other system, you can see it here, or you can get the download option from here as well. As I am on Windows, I will download the Windows version of Git and 64-bit setup. Our download is done. Let's open the folder and try to install this. Click on next, next. It's pretty easy installation. Just keep everything default and click on next. So our installation is done. Now if your installation is successful, then you will be able to see this here. When you right click, you will be seeing here git GUI here or git bash here. This shows that your Git installation is successful. We have installed the Git locally. The next thing that we will do is creating the local Git repository. How we can create a local Git repository? Let's go and see. So you go to any folder wherever you want to create the Git repository. Suppose I have chosen this folder and right click here and click on git bash here. Here you can directly make a directory here, or you can make the directory from the terminal. How we can make the directory? mkdir and the folder name that you want to give, git local repository, and you can see a new folder is created here. Now navigate to this folder. How we can navigate? cd, and for copying this folder you just have to double click on it, and to paste it the shortcut is shift insert. You are inside this folder. Now once you are inside this folder, you have to initialize this folder. In the git, how do you initialize any repository? The command is git init init, and you can see initialized empty git repository, and you will see a master here. It is not a folder actually, it is a branch that is automatically by default created once the git is initialized. The next thing that we would do is to connect this git local repository to our application. Which application? The Spring Cloud Config Server application. Then how do we connect a local git repository to our Spring Cloud Config Server? Just have to right click here and go to build path and link a source and select the folder, source folder. This is the folder that I created. Select it. The folder name is git local repository. Click on finish, and you can see that the git local repository is here. Now this folder is connected to your config server. In this config server, I want to create a new file, a text file. Let's say limits configuration, limit service configuration.txt. Click on finish, and the properties that I have used in the limit service application properties, I just want to take it from there and keep it here. I'll just copy it and keep it here. I want to change the values. Let's say I will keep this temp 20 and maximum is 2000. To save the changes. Now you have added a text file here. It will be picked up by this application directly. In the Git, you have to follow, when you are using Git, you have to follow some procedures. Like you have to first commit those changes, then you have to push those changes. How we can do that? You have to go to the folder where you have created your Git and right click on it. Click on git bash here. When you say git status, there are a few set of git commands that you should be learning so that it will be very useful. It's not much, but it will be very frequently used, so you can write it somewhere so that you can use it very frequently. So you can see here no commits yet, and in the red mark it is showing one file name. So this is the same file name that we have created just now. Why it is in the red mark? Because we have not actually added to the git. Added to the git in the sense, whatever the changes we make to this folder, that is being tracked by this git. So even if you change one space also, it will show that you have made some changes in this file and you have to move it to some memory, the git memory, so that it can know that okay, the changes are saved now. So that's how it is called a version control system. So how we can add this text file? The command is git add, and if you want to add only this file, you can just insert this file. And if you see a lots of file here in the red color, that means that one by one you cannot add it here. So you can just give git add -a and click on enter. That time it will add all the changes. Now when you again type this git status, now you will see this in the green color. That means that this file is now ready to be committed. So for committing it, you have to type git commit, and you have to give some message to the commit, that is -m, and in the double quotes the message -m means that message that you want to give. I will say this is my first commit and click on enter. So for the first time when we are setting it up, we have to give our email address. How we can set the email address? It is not taking the commit as of now because I have not given any global email address or username to this. So git config global, we have to add this command. Now let's try to commit it again. You can see here one file changed, 2 insertions made. Now when you type git status, you will get nothing to commit. Now once you have this changes committed, you can just click on git push. One more thing you should notice here, that git push will not work in your local because this is not a remote repository. Git push will be using just to push our code to any remote repositories. Like for example, if we want to push this code to GitHub, we have to use the git push command. Now let's move to the next step. The next thing that we will do is to connect our Spring Cloud config server with this local Git repository. So how we can do that? Let's go and see. We have made a text file here, and to give the location of this text file, we need to configure this in our application.properties. So which application.properties we will be making the change? We are connecting this Spring Cloud config server with our Git repository. So it's better to close all the other tabs while you're working with one of the service. So now here we need to give the path for our configuration file that is stored in the local repository. How we can give that? We can use Spring Cloud config server.get.uri equals, and you need to provide the location for your file. So where is the location? Just copy this location and paste it here. Now, so as this is a file, we have to give this annotation file : / and just save it. Now run this application as a Spring Boot application. You can see here that the Tomcat is started at port 8888. Let's go to the browser and open this port, localhost :8888 / you have to give the name of the file that you have it here. Copy this, paste it here, and /default. Click on enter and it will give you page not found 404 error. So why we are getting this error? Let's go and check it here. In this application, one more thing you have to take care is that this is a config server, and open the main class of this. You need to enable the configuration, otherwise your configurations will not work. So the annotation that you need to give is enable config server. Save it and wait for the changes to pick up. So we are getting an invalid server configuration. Our application is not able to start. And let's read out the error message carefully. Invalid config server configuration. If you are using a Git profile, you need to set a Git URI in your configuration. So the error here is it is not able to recognize the Git URI. Let's go and check it here. Okay, so the spelling should be config server. Okay, now it should work fine. So I can see that my Spring Cloud config server is up now. Let's go to the browser and refresh this. And now we are getting illegal state exception. Actually, when we are getting this kind of errors, we are covering all the scenarios where you people can get such kind of exceptions. So it's better that we are getting exceptions. One of the important sign of a good developer is to read all the exceptions completely, because these exceptions are meant for your help. So we can see here illegal state exception cannot convert URI to file. It's clearly saying that the error exists in this file name only. Let's go to the file, and the error is here itself. You have to change this directory name like this. Save it and wait for the application to pick up changes. The application is started. Now let's go and hit a refresh button. So you can see that our file is loaded, but we don't have the values here yet. And let's see why you're not getting the property source. So one more thing you should know from here, this should not be a text file extension. What I mean to say is that this file name should be .properties. Let's go ahead and change it. Right click and rename. Click on OK and wait for changes to pick up, and the server is started. Now let's go to the browser and click on refresh. So now you can see here we are getting the property sources with the limit service minimum 20 and the maximum 2000 that we configured. We are also getting the name of the properties file that is configured here. So till now what we have done is we have connected our Spring Cloud config server to the Git repository. And few things you should also notice, that this limit service and currency exchange service and all these microservices will be having multiple environments. So all these these environments based on the QA, the dev environment, and the prod environment, you can create a text file with the extension of prod or dev or QA. And in place of this default, that environment name will be coming. You can see that the profile here is default. You can keep it a dev profile. Based on that, it will pick up the properties file. One thing also you should take it from here, that in the application.properties, we are using this local file name. You can also point this to a remote repository. If you want to give the location of your GitHub, surely you can go ahead and keep it without any problem. In the real time, we will not be keeping it in our local. We will be keeping it in Git repository only. Till now, we have configured our Spring Cloud config server to take the values from the Git repository and display it on the browser. So as we discussed earlier, all these applications will be having different environments that we showed here. Like limit service will be having different environments, dev, QA, stage, and prod. So for each of these environments, we will be having different set of values. So let's go and configure all these different set of values in our Git repository. How we can do that? Let's see that. Go to the folder Git local repository in Spring Cloud config server, and you can see this is the default file that we created. So let's copy this file and paste it again here. Control V. You can change the name here. So suppose you want to change this name to dev, and let's open the dev file, and here we have just copied it from there. So we will change the value minimum to 2 and maximum to 2. Save this, create one more file and name this QA. Click on OK and open this QA file. Change the value 99999. Now we have three different set of files: the dev, the QA, and the default properties. Here in this application, we are using limit service, and the minimum value is 9, maximum value is 9999. In the real-time scenario, you can think like you are having different database for the dev environment, different database for QA environment and prod environment. So you can configure all your databases in here with username, password, the connection string, and all. For the QA environment, you can give QA username and password. For dev environment, you can give dev.db username and password. Suppose you are using a URL in your program and you are hard coding it in your program. If tomorrow that URL changes, you will have to go to the program and you have to change the hard coded URL to the changed URL. But when you are using this kind of configuration based things, you can just go to the properties file and you can modify your URL. So now we have configured the dev and the QA environments. Let's go ahead and check if we are getting the values. So in place of default, let's give it a dev. So when we give the value as dev, we are getting two property sources here. One is the dev configuration and the other one is the default configuration. Now why we are getting two property sources? That's because the one you have created here is a default property. Suppose you are not giving this property, you are commenting this out. So at that time, it is able to get only one property and the other property it will take from here. So how do we set the priority for this? Like which one will be picked? So these priorities we will set it when we are connecting this limit service to our Spring Cloud config server. Now when you change the value of environment to QA, the values will change. See, the QA properties is coming first and after that the default properties are coming. So this is the way we will be configuring our environments and its variables. Now let's go one more step ahead and let's connect our limit service to a Spring Cloud config server. Till now we were fetching the values of limit service from the application.properties of limit service, that is this one. We were fetching the values from here. Now we will not fetch the values from here. We will be fetching it from Spring Cloud config server properties file. So what all things you need to change for this? The first change that we need to do is to remove these two text lines from here because we are going to pick it from Spring Cloud config server. The other change that we will be doing is renaming this application.properties, because when we are using the Spring Cloud config server to pick up the properties, we have to change this name to something called Bootstrap. Let's refactor and rename this. Bootstrap.properties. Save it. One more thing you should notice here, that you have given the application name as limit service here, but in the Spring Cloud config server limit service configuration, either you can change the values here or you can rename this to limit service. It will be better if we rename this to limit service. Rename this as well. We are renaming all these three files. Now we have renamed all these three files. We have not committed the changes in our local Git repository. Let's go ahead and commit these changes. Go to this directory and click on git bash here, and you can check the status by using git status command. We deleted one with the name with the configuration, so it is coming here. You need to add all these changes. How you can add all these changes? By typing the command git add minus capital A, click enter. All these changes are added, and when you click on git status now, you will get all these in the green color. Now you have to git committed minus m in the message. Updated properties. So the changes are pushed. Now let's see if our limit service application is running. You can check that from the boot dashboard. Yes, it is running at port 8080. Let's go ahead and give localhost 8080 limits. That is the name to this. So we are getting here maximum is 0, minimum is 0. Okay, so still our work is not yet completed. Okay, why we are getting this 0 and 0? Let me tell you that. That's because we have removed the properties from here. We have given the name as a bootstrap. But how does this limit service application will know that you have to go and fetch the values from Spring Cloud config server? Because we have not specified anything from here. How we can specify that you have to go and fetch it from Spring Cloud config server? By giving the location of this application, Spring Cloud config URI equals to, what is the URI of this application? That is http localhost colon 8888. That's the URI that we have exposed this service. And one more change that we have to make is adding the dependency in our limit service POM XML. The dependency that we are going to add is Spring Cloud Starter config. Let's copy this and paste it in our POM XML. Make sure that the version of the Spring Cloud Starter config should match with the version of Spring Boot that you are using. So 2.2.2.release, that's the current version that I'm using. After that, you have to save this, and once you have to restart your limit service application. So my application is started now, and let's go to the browser and try to hit refresh. And now you can see that it is picking the maximum and the minimum values from the default file. We will learn how to set up the profile in the future. Now let's review on what we have done till now. So we created a limit service. This limit service is having a maximum and a minimum value that we first gave it through application.properties. After that, we created a Spring Cloud config server, and we created a Git repository where we will be storing all our properties. So ultimately, we are picking all the properties from this Git through this Spring Cloud config server. So currently, we are using this limits microservice. In the future, we will be making this currency exchange microservice and the currency calculation microservice. These all the services will be having different kind of environments, and all the environments properties will be stored in this one common location, that is a Git. And everything will be talking through a Spring Cloud config server. So this makes it very easy for us to maintain the environments, because there will be so many instances of all these microservices. And if we have this one common place where we can do all the configuration, it will be very easy for anybody to maintain the application. Later on, we will also be learning, like when we make any changes in these properties, our microservices is going to pick all these properties automatically. That will be learning at later point of time. So let's move on to the next step here. Now we are going one more step ahead, and we are going to create this currency exchange service. So this currency exchange service will be talking to a database by using JPA, and the currency calculation service will be talking to this currency exchange service. So the currency exchange service, why we will be using this? Suppose you want to convert a US dollar into Indian rupees. So what things we will be needing to convert a USD into a INR? Let's try to understand it like this. We'll be exposing our currency exchange at port 8000, and suppose we want to convert from USD to INR. So for that we will be returning something like this. from USD to INR, and the conversion multiplication that will be coming from the database, that is 75. After that, the currency calculation service that will calculate the total amount, and it will take the help from the currency exchange service. You want to convert a USD to INR, and how much money you want to convert. Suppose you have 10,000 USD and you want to convert this to INR. So conversion multiple that you get is 75 and the quantity that you have is 1000. So the total calculated amount will be your multiplication of 75 and 1000, that is 75,000 INR. So going forward we'll be implementing this currency exchange service and the currency calculation service. I will recommend you to do it from your side once. Once you have done the implementation, you can come and cross check your implementation with whatever I am doing it here. Now let's go one more step ahead and create our currency exchange service. So this currency exchange service, we are going to create one new microservice. So how we can create a new microservice? You need to go to Spring Tool Suite, just click on New and Spring Starter Project. And the name of the service, we want to give it as currency exchange service. This is a Maven project, packaging is jar and the language is Java 1.8. Form.techno tab, currency exchange service. Click on next, and here we will select what are all the dependencies that we need. We'll select web, the Spring Web. Then we will use DevTools. Next, actuator and a config client. Spring Cloud config client. So these four dependencies we will be using. Click on finish button and it will start downloading the dependencies. You can see it in the progress bar. So all the dependencies are downloaded now. Let's go and check. We have got, as obvious, the Java folder, resource folder, the test folder, the Maven dependencies, the form file. Let's open our application properties and give our application the name. Name our application. Spring.application.name equals to, this name should be same as your artifact ID. Currency exchange service. And the port that where we are going to run this application, that we have already defined it in the beginning. Currency exchange service will be running on port 8000. How can we name the port? Server.port 8000. Save it and let's run the application to check if everything is working fine. So you can see here Tomcat has started on port 8000. So our application is running fine. Now, as discussed earlier, we are going to expose this currency exchange URL. It will take a from value and it will take a to value. So basically this will be coming from a path variable. So let's see how we can do that. We will have to make a controller and expose this REST service. Go to the source folder and here we will rename this. This is a wrong naming that we have given. First of all, we will rename this package refractor, rename and make this from limits to make it currency exchange. Now let's go on and create a simple controller. We'll say this class name as currency exchange controller. Click on finish. Let me make it full screen so that you can view it very easily if you are watching on mobile. We will annotate it with a REST controller. Now we are going to create a method which will be returning us the exchange value. So first of all, you should have a clear understanding of the method that you are going to create. So this currency exchange service will be having one method that will convert this USD to INR. This from USD, this will be not USD always, this will be variable. So how do we define a variable here? We'll be keeping it like this, from and to. When you say like you want to convert from USD to INR, you will get the multiplication factor as 70. So let's go and do that in our method public. It will return an exchange value and the method name is retrieve exchange value, and this method will be taking two parameters, the from and the to. These two parameters will be coming from your path variable. How can we take a path variable into a method parameter? By giving path variable, that will be a string, and you name this string as a from, and you will also be having a to string. How can you pass a to string? Path variable string to, and this will be obviously a get method, so you will be giving get mapping, and you will be mapping it with slash what we defined in here, currency exchange, and this is going to be like this, from and to. Now obviously we don't have this exchange value class. Let's go ahead and create this exchange value class first. We'll be creating this in our model package, and the name will be exchange value. Click on finish button. Now in here, what we'll be having? We'll be having two fields. One is a from and one is a to. From. Let's define one more thing, the ID. For every exchange value, there will be an ID that will be a long format, and there will be a conversion multiple. To be practical, it should be defined in a big decimal format. So private big decimal conversion multiple. Let's organize the imports. Control Shift O. Now we should define a constructor for this. How you can define? Go to source and generate constructor using fields. We should also define a default constructor. And we should create a getters for it. Select getters and click on generate. So it will only generate the getters, and let's define a to string for it. So everything is done, and we have to return this here. So how we can do that? Let's, for now, we can return a hard coded from and to values. Return new exchange value, and we'll be giving an ID 1000, let's say, from USD, say string, 2 will be INR, and the conversion multiple. So how do you give a big decimal? Big decimal dot value of, let's say, 70. So this will be a L. Now save this and let's start our application. So our application is started. Now let's go and hit it. It should be localhost /:8000, then change value from and to USD into is, click on enter, and you will see that whatever we gave in the hard-coded string, that came up here. So till now we have created a currency exchange service which is hard-coded. The next thing that we are going to do is this currency calculation service is going to call a currency exchange service, and this currency exchange service will be having different instances. As you can see, we defined like currency exchange service will be running on different ports, 8000, 8001, 8002, like that. But currently we have configured only one instance of currency exchange service that is running on port 8000. Now we will create multiple instances of currency exchange service, and let's see how we can do that. Let's say we want to run this one more instance of the same service on port 8001, and also how we can determine like which instance of the currency exchange service is called. Let's go and do that. Currently we are having only 4 parameters here. Let's define one more parameter in exchange value here. Private int, say port. So the port number we will be giving it here. And I'm not going to make any change in the constructor. I'm just going to make a getter and the setter. Generate getter and setter for port and save it. Now you can set the port here. How we can set the port? So let's define a variable which is returning the exchange value and return this exchange value. And in this exchange value, we want to set the port, and we can give any port number. So currently we know that it is running on port 8000. So we have hard coded and given it 8000. But how can we set up dynamically? So there is something called environment in Spring Boot. Let's make use of it. Private environment. Import it is the Spring Framework core environment. This one you have to import, and let's auto wire it as well. Now we can dynamically set the port. So we have set the port in the application.properties server.port 8000. So when we check this environment, it will take the values from the application.properties. We can say like environment dot get property and the string key. So the key here is local server.port. We have this server.port, but why we have given local? Because by default these properties are set in the local environment. Now this is expecting an int value. What we can do, we can convert this into int. teacher.parse, save it and just run the application once. Port 8000 is already in use. Here we should not start the application, it is already started. Let's go to run the application. Now you don't see any port here as of now. Let us refresh it and we can see the port is 8000. So currently only one instance of this is running. How can you run the second instance of it? For running the second instance, what you have to do, there are different ways to run it. Another instance of this application. How we can do that? You can right click on the application and you can run as and run configuration. So when you run the configuration, by default this window will come. The name of the application is currency exchange service. This name can be anything. It is running on port 8000. Let's say that. Just a naming convention we have given and say apply. Suppose we want to run one more instance of this service, we can right click on it and say duplicate. So in the duplicate, you just need to give the name to this one. I just want to give this name, any name you can give, but to identify that it is running on port 8001, we'll name it like that and go to the argument, and in the VM args, you can give -d server.port equals 8001. Now apply it and run it. Another instance of this application is starting, and this will be started at port number 8001. Let's see. Tomcat has started on port 8001. Let's go to test our application. Let's copy this whole URL in another tab. Just change this port number and enter. You can see here the application is running on port 8001 and this application is running on port 8000 and both at the same time. So we can now say that two instances of this currency exchange service is running now. Now the next thing that we are going to do is we are going to connect this currency exchange service to the database. So here what database we will be using? So we will be using a S2 database. So if you don't know about S2 database, it's a very simple thing. S2 database is an in-memory database provided by this Spring. What do I mean by in-memory database? There is no any installation for this database. When you start the server, this database will be created, and when you stop it, this will be deleted. The advantage of using this database, it is very helpful if you want to test something or if you are making an application like this. How we can configure S2 database in our project? So there is a dependency for it. Go to your currency exchange service and pom.xml, and we will be using the JPA, that is Java Persistence API, which is a library for performing many helpful database operations. Let's see how we can do that. First of all, you will need a data JPA dependency. Name is Spring Boot Starter Data JPA. Now save it. It will download all the dependencies. The other thing we discussed is we want to have a S2 database. So for S2 database, we should define this dependency. The group ID for S2 database is com com.s2 database, and the artifact ID for s2 database is h2. So let's save it once, and it is downloading all the dependencies. Meanwhile, we should count this s2 database in our application.properties. S2 database is all with the Spring now. Just we want to say like enable this S2 console now. S2.console enabled equals to true, and also already available see what are the operation that is being performed by this JPA. So for that, JPA provides something called spring.jpa show SQL. If you give it true, it will print all the queries that are being performed in the backend. Let me stop the server first. Now you should be a little bit familiar with the JPA. If you are not familiar, then also fine. I will use some annotations and go through it. So entity, import the entity, Java X persistence. This entity represents the table. When you denote any class name with the entity, it will think that this is the table name and these are the columns of that entity, and it will consider the table name as exchange value. Suppose you want to change the table name, you can give the table name as here, annotations will be there, and at the red table, and you can give the table name. I want to keep it exchange value itself, and the fields in this entity will be considered as a column. So id is column, from is one column, to is one column, like that. You will be have a multiple column. If you are defining entity, there should be a id associated with that entity. So I'm saying like this ID is the primary key. I've denoted it as ID. So in the Spring, what happens? Like when you start this application, if it finds an entity somewhere, by default it will create a table in the database that you have configured. Here it is S2 database. It will create a table with name exchange value in the S2 database. If there is other database configured, it will create the table there. So this table will be created when the application starts. Now let's insert some values in this table. How we can insert the values in the table? So there is a fixed pattern for that. So you can go to resource folder and create a new file, and you have to name that file as data.sql. So it will look for a file called data.sql. Whatever the things you will give it in this file, it will initialize. So whatever the things you give here, that will be initialized and inserted into database. Let's say insert into exchange. What is the table name here? Exchange value. Let's copy this one, insert into exchange value. Now here this exchange value will be converted to exchange underscore value, because this JPA has some libraries which sees that this is an entity, and based on the entity name it converts the table into its own format, that is like this. So we have id, comma, from, comma, to, comma, conversion underscore multiple, comma, port, and the values we will give 1001, comma USD, comma INR, and the conversion multiple, let's say 70. And also we want to give a port number. By default, let's give it a port number of 0. Copy this, use it 2 or 3 times, make it 2, make it 3, and euro to INR, let's say 112 Australian dollar to INR 25. Now save this one and let's try to launch the application once. We will launch it on port 8000 first. Let's see. And let's check the console. So we have got an exception here, that is JDBC SQL syntax exception. So table exchange value not found. So but you have to read it very carefully, like why this error is coming. After reading through all the errors, I feel like there is some problem with the way we are creating the table. So here we have given this from and to. So this from is a keyword of SQL, and if we are using from here, then it will give us an error to select star from, and this from is a keyword, right? And we have given this as a table name, so we cannot give this same table name. How we can change this table name? Sorry, we have to change this column name. How we can change the column name? Go here in your entity class and just give @column, and the column name you should give currency from in the double quotes, and @column currency 2. Let's save this one and add the same in here as well, currency from currency 2. Save the file and run the application once again. So this port is already in use. Let's check it quickly. Let me start a port 8001. So you can see here currency exchange service application is started at port 8001, and these are the SQL operations that are performed, and it is logged in the console. Now how we can see the database? So you can see the database just by going to localhost colon 8001/h2 console. This is the port that your application is running, and at the same port this database will be started. Now these are the basic settings. What happens when we keep these default values and click on connect? We will not be able to connect this because we have to provide this URL in this format, that is jdbc h2 mem test db. Now click on test connection. It is successful. Now connect it. So you can see that this is the database, and this is the exchange value table that got automatically created. And when you run this select star from the table, so you will get all these values here. So in this step, what we did, in this step we have created a database, and we have initialized some values in this database that we will be using the JPA in this application. And let's see how we can do that. Now let's go one more step further and connect this currency exchange service to this database. So now we are going to pick up the values of this 2 from the database. How we can do that? We can do that by creating a new class, actually interface. Let's say that as a repository, the package that we will give is, name the package as repository, and the name of the interface is exchange value repository. Click on the finish button. We have to define this as a repository, and this interface extends JPA repository. JPA repository is having some set of different predefined methods that will make the things very easy for us. And it takes 2 parameters. The T is the name of the table that you are dealing with. In this repository, we are dealing with exchange value table. So what is the entity name for that? Exchange value. And what is the ID type of primary key? So the ID type of primary key, let's go and check here, is a long. So this primary key is having ID type as long, and we are done with the repository thing. Now in the currency exchange controller, we want to take this from and the 2 from the database. So for that, what we will need is a query parameter. Suppose let's create the instance of our repository here, or to add. So you can see that this exchange value repository has so many predefined methods like delete, delete all, find one, find by id. One thing which we need is to find by from and to. We don't have already defined it there, but JPA has this magic to do that in very simple format. You just have to type find by, follow the same naming convention, find by from and to. This from will be used from the entity from and to. Okay, and in the method parameter you should give a string from comma string to. And what is the return type of this one? The return type is exchange value. Okay, and this is the magic it does. When you call this method find by from and to, it will return you a row that will be having all those values. Let's call this method from our controller repository dot find by from and to. This is the one we defined. Close the method. Now we don't need this thing. Okay, now save it and relaunch the application or wait for the application for changes to pick up. Let's see the console, what is happening. So our application is started and running on port 8001. Let's go here and it is 8001. See, the ID is 1000 here. Now let me refresh it. The ID is 10001, that is coming from the database USD to INR multiple the port number. Now let's see what if we are giving to euro to INR. Click on enter. 1002 euro to INR 112. Like that you can check for others. And what if you are giving DNR to INR? So this will be giving some error because obviously we don't have anything in the database. With this we can add some exception handling in our application, but that we will do it later. So this completes the currency exchange service. We have connected our currency exchange service with the database successfully. Thanks for watching.
Hello everyone. So in the last video we learned about currency exchange service and we connected this with our database. And in this video we will create a new microservice, that is a currency calculation microservice, and we will connect this with currency exchange service. So let's understand it from here. So suppose you are an end user. By end user what I mean, you don't know what is the backend of the code and you just have $1000 in your hand. So you just enter this $1000 and you want to know what is the expected amount that I will get if I convert that to INR. So you just enter the quantity, the conversion multiple will be picked up from the database and you will get the total calculated amount. So let's go and introduce our new microservice, that is a currency calculation microservice. By now you already know how to create a new microservice. We will keep the name of the project as currency calculation service, and the group will be com.technotab and the artifact ID will be same as the name of the project. The package name will be com.technotab currency calculation. Click on the next button and here you will get the dependency that you have to add in your project. We will keep it web, the dev tools, actuator and the config client. After selecting all these 4 dependency, let's click on the finish button. We have got the project and the dependencies are getting downloaded. So let's wait for the dependencies to get downloaded. Now that we have downloaded most of the dependencies, run the project once and check if everything is working fine. So you can see that the Tomcat is started, so our application is working fine. Let's stop the server once and let's go to implement whatever we discussed. So now we are going to create a new controller. In the package controller, and in this package we are going to create a class called currency calculation controller. Click on the finish button. So this is obviously a REST controller. Let me increase the font size first. So this is obviously a REST controller, so we will annotate with the REST controller annotation, and we are going to expose a API, that is a GET request API, get mapping. The URL will be whatever we discussed. This will be the URL, where this from value USD will be coming from our path variable, and the to value will also be coming from the path variable, and the quantity as well will be coming from the path variable. Now let's wrap it into a method, let's say public, and the method will return the calculated amount, and the name of the method we will give is calculate amount. So obviously this method will return calculated amount. For now let's return a null value. We discussed three things will be coming from the path variable: the from, the to, and the quantity. So let's define it in the calculated amount. How do we define a path variable? @ path variable string amount string, sorry, this will be from the to variable, comma, and one more path variable, that is the quantity, and this quantity will be a big decimal. Now obviously we don't have this calculated amount class. Let's go ahead and create this class calculated amount. I will keep this in a models package. Now in this class we will have a ID which is of type long, then string, a from value, then a to value. Then we want to have the multiplication factor as well, and this multiplication factor will be a big decimal. The next thing is the quantity that you have entered, and finally after multiplying with the multiplication factor you will get the total calculated amount. One more thing, we will add a port number as well. So we have got this class. Now let's give a default constructor for this class. Again we will make a parameterized constructor. You already know how to make it. Go to source, generate constructor using fields, select all and generate. Now you also know how to make a setters and getters for the fields. Select all, generate, and also we will give a toString. So in this class we have a default constructor, a parameterized constructor, the setters and the getters, and the toString. Now let's come to our controller class and let's return whatever the values we have created. We will return the calculated amount. First we will return a hard-coded one, the new of calculated amount with the parameterized constructor. ID we can give anything, we will keep it 100. The from value will be coming from your path variable, the to value will be coming from your path variable, the multiplication factor will be coming from the currency exchange service. For now let's hard code it and give it a big decimal, and for now let's give it a 1, and the quantity will be coming from your path variable. The total calculated amount will be the multiplication of this multiplication factor and the quantity, but for now it will be a big decimal. For now let's give it quantity. The port is a int value, let's give it 8100. ID will be a long format, it will be L. Now save this. One more change that we want to do is we have not named this application. Let's go ahead and name this application, and the name of the application we will give it same to same whatever we have the artifact name, that is currency calculation service. And the port number that we want to assign to this application is, we discussed whatever we discussed earlier, that was 1800. So let's go ahead and give the server the port 8100. We will save this application and we are ready to launch up the application. Tomcat is started on port 8100. Let's go ahead and grab this endpoint and start the browser. And we will give this from value as USD, to value as INR, and the quantity as 5000. Click on the enter and you will get this response. So the ID is 100, from is USD INR, multiplication factor is 1 because we given that value as 1. Now the quantity that we gave is 5000 and the port that is 8100, that is a hard coded one, not taking from the server.port, it is hard coded one. Now the total calculated amount is 5000. So we have got what we wanted. Let's make some improvement in our class, and our next step will be to connect this currency calculation service with our currency exchange service. Let's see how we can do that. So what changes we have to make in order to get these values? So now all the values will be coming from our currency exchange service. So how do we invoke the currency exchange service from our currency calculation service? We have to use something called REST template. Then one more thing we have to make sure, like your currency calculation service will only work when your currency exchange service is up and running. So let's make this currency exchange service up and running. We will start it on port 8000. And in the currency exchange service, we will be calling this method or the URL, and this method will give us whatever the data that is coming from the database. First, let's start the currency service and check what is the output that we are getting here. Localhost 8000 from USD to INR, and these values are coming from your database. So this currency exchange service is giving us this data, and the same data we will be using in our currency calculation service. So how do we invoke our currency exchange service from the currency calculation service? We have to make use of something called REST template. In the currency calculation service controller, we will be making use of the REST template, new REST template, and the method that we are going to use is get for entity. Whatever the fields are there in this URL, we'll be making use of it directly. Let's copy this whole URL and paste it in here. This will be a string URL, so it will be in double quotes. This from value will be coming from the path variable, and the to value will also be coming from the path variable. Now in this string, if you are giving this string, this will not work because this is in the string format and this from and to will not be recognized. How do we get this recognized? We have something called path variables. So the path variables, when you define it in a key value format, whatever you map within this path variable, that will be coming in this from and to values. The response type is the type of response that we are going to receive, that is the calculated amount dot class. Now the URI variable we have to define, and the URL variable, how we can define it, map format. We'll say map of a string, new hash map, and in this URI variable we will put the from and the to values, and the value from is our from the URL, and we will keep this to value from the URL. This is the value of the to, and this is will be going in this URL. So this line will fetch all the objects from this URL. So let's store it somewhere. We'll say response entity, and the response entity will be of the type calculated amount. Now you have everything available in this response entity. So response entity will be coming as a whole package with this response body, the status code and everything. So from there, from the response entity, we want to get only the body. So response entity dot get body, and this method will give the body of the response entity. We will store it in somewhere. So and now from this calculated amount, we will be using all the values from there. So calculated amount dot get id, that is also coming from currency exchange service. The from value will be coming from your currency exchange service, correct? Dot get from. Let's move this to the next line. Then again currency exchange dot get to. Now this big decimal is your multiplication factor. So the multiplication factor will also be coming from your currency exchange dot get multiplication factor. Then again this quantity is quantity that end user has entered, that will be coming from the path variable, that we will leave it as it is. This is the total quantity, that is, and what is the total quantity? That will be the multiplication of the multiplication factor and the quantity that you have entered. So quantity dot multiply, and what we are going to multiply, this multiplication factor, and the port that will be also coming from our currency exchange dot get port. Save this and wait for the application to pick up the changes, and let's go to currency calculation service, and we have entered the amount. When you click on enter now, see what happens to the total calculated amount. So there is a null pointer exception where the multiply dot unknown source. So let's go and check what is the problem here. So the problem here is that your get multiplication factor, there is nothing called get multiplication factor in the currency. The field that is different from the currency exchange service is your conversion multiple. We should make sure like all the fields in the currency exchange service should be matching with the fields in currency conversion service, or it will give you an exception. There are two things that we can do. We have to make a class which is same to same as the currency exchange service, and the other thing that we can do is by using mapper classes. So we can map this conversion multiple with multiplication factor. So which will be the easiest thing to do? If we are going to map, we have to create a mapper class, and then we have to create the mapping and extract the values here. But what happens when we change this get multiplication factor? Just by making only one change, we can get this multiplication factor. Why can't we do that? So for that, we have to make only one change, that is, in place of multiplication factor, we have to give only the conversion multiple field. So conversion multiple, if we can use this one, and if we refactor this, click on enter, it will change at every place. We have to give this conversion multiple, refactor this again. So after changing this conversion multiple, we have to change the constructors, setters and getters, and the toString method. Let's do that one by one. We'll generate the constructors, then we will generate the getters and setters, and at last we will generate the toString. Again, after changing this in the controller, you will get some error. Let's go and resolve this. This will be get conversion multiple. Here as well we will get the conversion multiple. Now save your application and let's go and check the output. Refresh it and you will get the output. So the conversion multiple that is coming from the database is 70. The 5000 is the quantity that you have entered, and the multiplication of 70 and 5000, that is 35,000 Indian rupees. So make sure your currency exchange service is running, then only you will get the output in currency calculation service. So thank you for watching. We will move to the next step in the next video. Goodbye till then. Welcome once again. So in this video we are going to learn something about Feign. 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 So what is the Feign? In this application we have two microservices here. One is the currency calculation service and one is a currency exchange service, and we are making call from currency calculation service to currency exchange service by using something called REST template get for entity, and we are doing so many lines of code here. But Feign, what it does, you just enable this configuration and it will do everything for you. Here we have 2 to 3 microservices and we can make a REST template call and it will be easy for us. But in the real-time environment, there will be hundreds of microservices, and if you are adding this REST template call for in all the microservices, it will simply increase your lines of code, and you can do that easily with the Feign. So how do we configure Feign? For enabling the Feign, you need to add a dependency in your pom.xml. Copy this and add this in the pom.xml of microservice from where you want to call. So in here under dependency section, we are going to add this dependency, and it is provided by Netflix. Click on the save button, it will start downloading the dependency. So if we are going to use this Feign, it will not work because the dependency name after I think 3.0 it changed to open Feign. Let's save it and see if it works. Yeah, so it is downloading the dependency. That means it will work. So the dependency is downloaded. Let's go and enable the configuration. We need to go to currency calculation service application, and in here we need to enable the Feign client, and you need to provide the package that needs to be scanned for this. So I will give this package name. Then the next thing that we need to do is to create an interface that will proxy this currency exchange service. So we will create an interface. Basically, whenever we are making a call from one microservice to other microservice, or from one system to an external system, we are naming that as a facade, and the name of that will be giving it as currency exchange proxy. So currency exchange proxy will be our interface, and in this interface we need to again make @Feign client, and in here we need to provide the name of the application which is going to be called. So the name of the application is currency exchange service. We will take the name as it is from the application that we are going to call. That is, in the resources we have given the name of this service as currency exchange service. We will copy this name and we will give it in the name field. Again, we need to also define the port where it is hosted. So the URL where it is hosted is localhost 8000. Now one more change that we have to make is we have to define a method in the currency exchange proxy, and this method will be coming from your currency exchange controller. Let me go to currency exchange controller, and I will copy the method that is here, the method name only, and I will keep it in here. We are not going to import this, and the return type here we have to change it because we don't have anything in this microservice. We have something called calculated amount, and the method name is, let it be like that. We cannot have a body in here because this is an interface, and we also need to have this mapping name. So this mapping name is from currency exchange controller. That is the same URL where we are going and hitting this currency exchange controller, and it is giving us the conversion multiple from the database. We need to have this get mapping here, and this from and to is not defined. So in the path variable, we need to also define this from and path variable 2. Okay, now we just need to call this proxy class from our controller of currency calculation service. Let's go ahead and create a method. We will create a new method. We will not touch this method. We will create a new method same to same as this one, and we will give the get my ping URL Feign, and the name of the method also we will change. So now we can go ahead and remove this code from here. And now how do we call the proxy class? So we need to make an auto wired call, and the interface name is currency exchange proxy. Now we can say proxy dot, the method is retrieve exchange value from, and 2 will be from your method parameters of here. Then we will assign this to a calculated amount. This is a variable of calculated amount variable. So now you can save this, and now let's go to run our application. So we are calling this Feign. From is USD, the 2 is INR, and the quantity is this time $500. Click on the enter. The site can't be reached, so we have missed something out here. That's why the application is not launching up. So one more thing we have to check here. In the currency calculation service application, we have given this Feign client. Actually this should be enable Feign client, and let's wait for the application to pick up the changes. Now the application is started. Let's go to the browser and click on the refresh button, and now you can see that our Feign service is totally working fine. So this is how we connect one microservice with the other microservice. The next video will be on balancing the load using the ribbon load balancer. So thank you for watching. See you in the next video. Hello everyone. In this video we are going to learn about ribbon load balancer. So what is a ribbon load balancer? Let's learn it in the real-time example. Suppose we are having different instances of this currency exchange services running on different ports, and we have a currency calculation service that is internally calling currency exchange service to get the data from database. So at a time, if we configure like one instance of this currency calculation service is going to fetch the data from currency exchange service which is configured at port number 8000. In the real time, if you have 1 or 2 requests, that will totally work fine. But what if you have 1000 requests at a time? Your currency exchange service will not be able to take the load and your application will crash. So to overcome this, we will be using this ribbon balancer feature, which will distribute the load between different instances of currency exchange service. So if you see here in the code that we wrote in the last video, there we use the Feign client and we give the URL as localhost 8000. That is the currency exchange service we are calling, which is hosted at port number 8000. So let's see what all things we need to change in order to configure the ribbon load balancer. So the first things first, you need to have a dependency that will be used to enable the ribbon load balancer in your application. And the dependency is Spring Cloud Starter Netflix Ribbon. If you are using a higher version of Spring which is above 2.0, you will be having this dependency. If you are using a lower version of Spring, you don't need to use this Netflix. So let's go and add this dependency in our pom.xml of currency calculation service. This is the caller application and we are going to add the dependency in here. Save this, it will download the dependencies. So as you can see, it is downloading all the dependencies here. Now the next change that we will have to do is we are using this Feign client in our application, and in there we have given this URL. First of all, we have to disable this URL so that it will not go and hit every time this URL. So we will make a copy of this, kept it here. We will disable this one and we will remove this URL from here. The next change that we will do is we will use an annotation called ribbon client @ribbon client, and the name will be the application which you want to call the currency exchange service. Now the next change that we have to do is in the application.properties of currency calculation service, make sure you are using this, and you have to provide the name of the calling application, that is the currency exchange service application name, that is this one, .ribbon name of servers equals, and we have to provide the URLs where our currency exchange service is launched. So the URLs are localhost 8000, localhost 8000, localhost 8001. These are the two URLs where our currency exchange service is hosted. You are done with the ribbon load balancer. Now it's time for us to test the application. First of all, both the instances of currency exchange service should be working. Let's go and check it if it is working. So we have to launch up this currency exchange service that is running on port 8000 and 8001. We already have this two instances of this currency exchange service created, that is using port 8000 and 8001. If you want to launch any more instance of this currency exchange service, you can just go to currency exchange service and click on run and run configuration. You want to duplicate whatever is already available. This is available, we will right click it and duplicate. And in the duplicate, we suppose if we want to run this on the port 8002, just change the name of this application and go to the arguments. In the arguments, you have to give the d server.port equals to 8002 and click on apply. You can see the new instance of this application is created. We don't want to run, we will close this, but we want to run the 8000 and 8001 instances. Let's launch up these two instances. We will also launch of 8001 instance. So our 8000 instance is up. Let's go and check it. So it's giving us the results. Now let's check up the other instance, 8001. We are getting the result from both the instances of 8001 and 8000. Now it's time to launch of our currency calculation service. And if everything is working fine, then we should be able to see the load getting distributed between server 8000 and 8001. So our currency calculation service is up now. Let's go and launch up currency calculation service, and the port information that will be coming will be displayed here. That is a dynamic port configuration that we had done in the currency calculation service. So when you hit on refresh, we are getting this load balancer does not have available server for client. Let's try to fix this. This seems like we have made some mistake with the configuration. Let's go back and check it. So you can see the name of the server. This is not the exact name that we have to give. The exact name that we will be using is list of server, not the name of servers. We will save this application and wait for the application to pick up the changes. Let's go back to our URL and hit refresh, and now you can see we are getting the successful response. So this time the port that is giving the response is 8000. Let's hit refresh button again, and now you can see the port that is giving the response is 8001, 8001. So now we can conclude that our ribbon load balancer is working properly and it is distributing the load between our two servers that is configured on 8001 and 8000. So in this video we have successfully configured our ribbon load balancer. In the next video we will move to the next step. Thanks for watching. Welcome everyone to the new session. In this session we will learn all about Eureka naming server. In the last video we implemented the ribbon load balancer, and now we will learn about this Eureka naming server. Let's understand the problem statements first. Why do we require the Eureka naming server? So currency calculation service is talking to currency exchange service via this load balancer, and we have two instances of this currency exchange service running. So what if I want to make this third instance up and running? Will the load be distributed directly to this all three instances of currency exchange service 3? No, right? We have to make some changes in the code, correct? And you can see that we have added list of servers, and we have to add one more URL so that the load will be distributed between all the three servers. So is it feasible to make a change in the code every time we introduce a new instance of microservice or we reduce it? No, right? So for that we have something called Eureka naming server. When we introduce this Eureka naming server, there are basically two functions of it. The service registration, that is, whenever you create a new microservice and you have Eureka naming server in place, this microservice will be getting registered with the Eureka naming server, and this process will be called service registration. Now if you want to make the call from microservice 1 to microservice 2, it can make a call directly like how we implemented in the last video, or it can make a call through the Eureka naming server. So each instance of microservice 2 that is created will be getting registered with the Eureka naming server. If you want to make a call from microservice 1 to microservice 2, it will go to Eureka naming server and it will discover how many instances of currency exchange service are running currently, and it will distribute the load accordingly. So this process is called service discovery. So that will reduce our lots of boilerplate code, and it will be very easy to maintain for everyone. Now let's move ahead to the next step where we will create this Eureka naming server. So there are a couple of things we need to take care before start using the Eureka naming server, and those are basically you're creating the component for Eureka naming server, then register all the microservice with the naming server that we will register one by one, and we will configure the ribbon load balancer with Eureka naming server. So we have divided this into 3 steps, out of which we will be going with creating the component for the Eureka naming server first. So let's start with creating the component. You already know that how to create a new Spring Boot project. You just have to go to Spring Starter project, and I will walk through it very quickly. So I will name the application as Netflix Eureka naming server. I'll keep the group ID as com.technotab Eureka naming server, com.technotab Eureka. I will keep the package name as Eureka naming server. Click on the next button, then we will download the dependency that is needed here, Eureka server, the dev tools, then we will use config client, and the last thing that we'll use is actuator. Now click on the finish button and wait for the dependencies to be downloaded. So our Eureka naming server has downloaded all the dependencies. Now let's go and check what all things we have got. Open the main application Netflix Eureka naming server, and we need to enable the Eureka server. So the annotation that we will use, enable Eureka server, import the dependencies. Now we are going to add one more basic change in our application. We will go to the resource folder application.properties, and here we need to add some few lines of code. Already you know that. Spring application name we will give same to same as the artifact ID, Netflix Eureka naming server. Then the server.port we will give is 8761, that is the default port of a Eureka naming server. Now these 2 lines of code we will see this later. For now we will keep it as it is. Now we will save our application and we will launch of this Eureka naming server to see if everything is working fine. So our Eureka naming server has started on port 8761. Now let's go to the browser and check the status localhost. When you give localhost colon 8761, you will be able to see this UI. If you are able to see this UI, that means that your Eureka naming server has launched up and you don't have any problem with your setup. Now you can see the instances currently registered with Eureka. There are no instances currently registered. You can see the system status here. We are going to see everything in here step by step. We will register all these microservices here. So let's move on to the next step. The next step will be to register your microservice with Eureka naming server. Let's go ahead and do that. We will be having certain steps for registering our microservice with Eureka naming server. We will have to add some dependencies in our client code. So the dependency that we will be adding is Netflix Eureka client. Let's copy this and paste it in our application. We will be configuring first of all the currency calculation service. Go to pom.xml and paste the dependency here and save the project. It will download the Netflix Eureka client dependency. The next change that we have to make in order to register with our Eureka naming server is we have to add annotation in our main application. Go to the main application and you have to add the annotation in our discovery client. Import the dependencies. The dependency that got imported is Cloud Client Discovery, enable Discovery Client. Now the last change that we have to do is we have to add something in our application.properties, and that will be the URL of our Eureka naming server. So our URL of Eureka naming server is localhost 8761 Eureka, and we will use this property Eureka client service URL.default zone. Paste it in our application.properties and save the application, and let's launch up our currency calculation service. Similarly, we will do this for other services as well, the currency exchange service and the limits service. So there are so many things that will be going in our logs. You can open the logs and see what's going on inside. Now let's go to the browser and hit on refresh. So as you can see here, the currency calculation service is the instance that is registered with Eureka now, and it is running on port 8100. Only one instance is up. Now let's register our other microservices as well. Currency exchange service, we will add the same dependency in pom.xml. Let me quickly do that. Now we are going to launch up the two instances of currency exchange service. It's starting up. So all the instances are up. Now let's go to the Eureka naming server and click on the refresh button. So here I'm not getting the instance of currency exchange microservice, and I had to pause the video, and when I click on refresh, again I will get the instance of microservice. So it took me a while to understand why I'm not getting the second instance of microservice. So the version of Spring Cloud that I was using, that was different across all my modules of microservice. So I had to go and check one by one in the pom.xml the spring.cloud.version, and I figured out like I have to keep the version of the Spring Cloud same across all my projects. So go to the pom.xml and check the version of a Spring Cloud that you are using, and keep the same Spring Cloud version across all your modules, and it will work for sure. So we have already configured our Eureka naming server, and we have also configured our ribbon load balancer. So we have everything in place now, the ribbon load balancer and the Eureka naming server, and we have to just make use of Eureka naming server to make use of ribbon load balancer to distribute the load between all the instances of microservices. How we can do that? Let's see that. So You can see in the application.properties, we made use of list of servers to hardcode all the instances of currency exchange service. Let's go ahead and comment out this line of code and our all the problems will be solved. So how it will work, we have made use of this something called Feign client to give the name of the microservice, and we have the ribbon client name. So we will be making use of both of these for registering and discovering our instances. So let's start it from the beginning once. We have to stop all the instances which are running, and we will go one by one, starting each of the servers individually, and then we will check the results. So let's stop all the instances. So select the Eureka naming server from the boot dashboard and click on the start server button and wait for the server to restart. So as you can see, our Eureka naming server is started. Let me refresh it again, and we can see there are no instances registered as of now. So let's go to start our currency exchange service first. So we will only start the first instance of currency exchange service. Select currency exchange service and click on the start button. So our currency exchange service first instance is up. Let's go to our Eureka naming server and check if it is registered. So yes, we can see only one instance of currency exchange service is started, and that's okay. Let's go to check if it is giving the response, and yes, we are getting the response from the server. Now go ahead and start our currency calculation service one instance. So click on the currency exchange service from boot dashboard, select the start server button. So our currency calculation service is up now. Let's test the application. We'll test the URL which has a Feign client extension, and we will see if we are getting the response back. So we are not getting the response back. We are getting some exception which says connection timed out exception. We will check if it is registered with the Eureka naming server. So currency calculation service is already registered with Eureka naming server, but we are not getting the response from there. So you have to give some time for it pick up the changes, maybe 1 minute or two. And so after that you have to give some time, and after that you click on the refresh button. You will be getting the correct response from Eureka naming server. If you are not getting still not getting the response after 1 or 2 minutes, you have to restart your Spring tool suite and go back and check your Spring Cloud version that you are using in your currency calculation service. Just go to the pom.xml, and there you make sure like whatever the version of Spring Cloud you are using, that should be same across your all the application. The Spring Cloud version and the Spring version that you are using should be same across all your applications. Then only this will work. So now let's go ahead and check the output. We are getting the output from port 8000. Now let's go to start our second instance of currency exchange service. So our currency exchange service second instance is up now. Let's go to Eureka naming server and click on the refresh button. And as you can see, we have got two instances of currency exchange service. Now we will go and check our currency calculation service. As you can see, it is on port 8000. Hit it refresh 1 or 2 times. It is still at 1000. Wait for 1 or 2 minutes for it to get discovered. Keep on clicking. So now you can see after around 30 seconds I'm getting the response from 8001 as well. And if you click on refresh 1 or 2 times, you will say that the port number is varying alternately from 8000 to 8001. So that means that our load balancer is working perfectly, and we have not hard coded any instance of currency exchange service. So our Eureka naming server is working perfectly fine. Hope this might have helped you. If you are still getting some problem, write it in the comment section. So this completes our configuration of ribbon load balancer and the Eureka naming server. And in the next video, we will talk about how we can configure application gateway. So thanks for watching. See you. In this video, we will talk all about APIs gateways. We will be coming along with different features of API gateway and how we can implement that in our project. Till now, you can see that we have implemented 5 different projects in our application: the currency calculation service, the currency exchange service, and the limit service. And along with it, we have created a Eureka naming server and a Spring Cloud config server. So for all these microservices, we will need to implement some of the common features. This can be authentication and authorization, or rate limit. That is, if you want to execute a certain number of requests, say 1000 requests per hour or in a day, so for that we can use the rate limit. Or if your application, or say one microservice, is dependent on another microservice and that microservice is not up and running, so in those kind of situations, we need to provide a default output to the calling microservice. So that fault tolerance needs to be implemented in the place. And service aggregation. What is service aggregation? Suppose a third party application is using your 10 APIs. So you cannot provide all 10 APIs. In the real time, it can be more. So you cannot provide all the 10 APIs implementation to the third party customer. Instead, you can provide just one endpoint, and internally you can connect with your 10 APIs and provide only single implementation to the end user or to the third party customer that is using your service. So that's called service aggregation. So these are all the features that you cannot implement one by one at the individual microservice level. These features only you can implement at the gateway level. So in this video, we are going to learn all about that. In this project, we are going to use a Zuul API gateway that is provided by Netflix. So we will be learning how to implement a Zuul gateway. There are 3 steps in implementing a Zuul gateway in your project. First of all, you will create a component for the Zuul gateway. That is nothing but a Zuul microservice they will create. And the second thing is what your Zuul gateway will do. What are all the action that it has to perform when it intercepts any request. And the third thing in the Zuul gateway is make sure your API gateway is hitting the correct microservice and giving the correct response. So these all things we will be looking. Now let's start with the step number 1, that is creating a Zuul microservice. So now we are going to bring a starter project. So you already know how to create a new project. Go to file, new, bring a starter project. You need to change the application name that you want to give. The name we are giving is Netflix Zuul API Gateway Server. Artifact ID, that will be same. Then the package name will be Zuul API Server. Click on the next button. Now here we are using the constant version of Spring, that is 2.2.2. There is nothing to worry about that. We will change that later. Let it be 2.4.2. Now let's see one thing here. If you type the Zuul here, you will see that you will not be able to add that. That's because Zuul is now deprecated, and if you are using a version of a Spring that is greater than 2.4.0 or less than 2.0.0, you will not be able to use the Zuul API gateway because that's in the maintenance phase and there is no support for this. So what we are going to do, we will keep this 2.2.12 for now, and we can add the Zuul to our dependency. We will change that version later. Then we will need a discovery client, so Eureka discovery client. Then the next thing is actuator and DevTools. So we have got all these 4 dependencies. Click on the finish button. It will start downloading the dependencies. Now if you see here, we are using this Zuul API gateway in the pom.xml. Let me stop this update first because we don't want this version of jars. We are using 2.2.2 consistently across our all microservices, and we will keep it as it is. And the Spring Cloud version that we are using is Exton SR1. So after that, let me save it and let me update it. So it will download the dependencies. It will take some time if you are downloading this for the first time. Let us see what all the things we have got in this pom.xml. We have got actuator, and we have got Spring Cloud, Netflix Eureka client, and Netflix Zuul. then the dev tools, and that's what we have got. The dependencies are downloaded, and let's start our development of Zuul API gateway. The first step we have completed, that is creating a new component that we have created already, and let us add some compulsory annotations here. That is, we are going to enable the Zuul API proxy. So the annotation that we will use is enable Zuul proxy, and the next thing is we will enable the discovery client. So we have done the compulsory changes. Now let's go to the application.properties and name our application. Let me copy this from any other application so that it will be easy for us to change it. We'll go to currency calculation service and let me copy this. And we will use it in our Zuul API gateway server. The name of the application, Netflix Zuul API gateway server. We'll keep the name as it is. So the port that we decided earlier that we are going to use for this project. So this is for the people who don't know, this is my website technotabs.com, and here you can refer all those projects and download the source code from here. You just need to go to Spring Boot section here, and if you go to Spring projects, it's still in the development phase. All the things are not yet developed. So microservice project with Spring Boot and Spring Cloud, if you click it here, you can download the source code. The latest will be uploaded here, and you can see all the port configuration that we decided earlier. I have kept it here. I will keep on updating these pages. The port that we are going to use is 8765. 8765. Where is our Eureka located? That we will leave it as it is. Let me save my application. We are done with the compulsory things that we have to do in our application. Let me zoom a bit because this will not be visible. I'm really sorry I didn't say this, but let me show you again. Let me zoom this one as well. Okay, this is okay. I hope you can see it more easily now. So the next thing is that we are going to do is we are going to create some of the components of Zuul API gateway server. The first thing that we are going to do is we are going to implement a Zuul API gateway logging filter. So we will create a class and we will name this class as Zuul logging filter and click on the finish button. So first of all, this is a configuration. So we will give @configuration. This class should extend Zuul filter. Zuul filter has some predefined methods that we have to implement if we want to extend this class. So let's see what are all those methods. So you can see that there is a method called should filter, the run method, the filter type, and the filter order. Filter order is nothing but the order in which you are going to run this application. So you can return the filter number as 1 or 2. What is the order of your filtering? Let me remove these comments here. The filter type. So what is the filter type? So the filter type is nothing but you define whether you want to run this filter after your request has executed or before your request has to be executed. Basically, we use terms like pre and post, or if there are any errors, we have to filter that out. So we define the type of filter that we are going to use. In the run method, it's nothing but your actual implementation. What you want to do, you can keep it here. And the should filter, if you want to skip this filter, you can just make it false. By default it is false, but we don't want to skip this filter, so we will keep it true. And in the run method, your actual implementation goes in. If any request comes in, I want to get the instance of that request. We'll be using request context dot get current context dot, we'll use get request. Okay, so we have got the current request. Let me save it to somewhere. Let's say HTTP. Let's say it is a HTTP servlet request, and we will store that in a variable request. Okay. We want to perform a logging of the request. So let me get the Slf4j logger instance here. So how do we get an instance of Slf4j logger? Logger Slf4j logger factory dot get logger, and the class name Zuul logging filter dot class. So we have got the logger. Now you can use the instance of this logger to log your request. Logger dot info. In the message, we want to show that what request it is getting. We'll give it request URL, the namespace, then we will give the actual request that we have already got it here. and we don't want to return anything from here. And this run method, let it return null. We just want to log this request. Let me save this and let's start our Eureka naming server first. So I'm going to start my Eureka naming server. I'm also going to start my exchange service. So there are 3 instances of currency exchange service. I will start only one instance that is running on port 8000. We will also start our currency calculation service. So give it run as spring boot app. My STS will start misbehaving now because I have started 4 different applications. That's not a problem, but let's see. Let me open the boot dashboard so that we can see what are all the applications that we are running. Netflix Eureka naming server is up. Currency exchange service is up. Let me start the Netflix Zuul API gateway as well. So you can see that in my boot dashboard all the 4 applications are up. Let me go to Eureka naming server. You can go to the local host. What is the port for Eureka naming server? Let me check it. It's 761. So let's see what's happening here. We can see that there are 3 instances. That currency calculation service is up, and the currency exchange service and the Netflix Zuul API gateway server is up. So this is what we wanted, and let us execute any request. Will it go through the Netflix Zuul API gateway server? Let's go and check it. We have not configured our requests to go through Zuul API gateway. So what we can do, let me try to execute any request if it is going directly or if it is going through Zuul API gateway. So click on this localhost colon 8000. Let me go to the controller of currency calculation service and take any request. So the currency converter to and from, let me take this. Okay, the from I want to keep it USD to INR and the quantity 1000. Click on enter. So there is no mapping to this. Let me change. So there is no mapping, obviously. 8100, the port that we're using is wrong one. 8100. Click on enter, and you can see that we have got USD from USD to INR. The conversion multiple that we kept it earlier is 70, quantity is 1000, and the multiplication, so we are getting it. Let's check on the logs once how it is going. So if you want to see a particular microservice log, you can click it here and you can go to that microservice. If anything is happening through Zuul microservice, let me clear this console and again hit a refresh button. So if anything is happening on the Zuul microservice logs, you can see the currency exchange service logs are only coming here. We change it to Zuul microservice, and you can see that the Zuul microservice logs is blank. That means that nothing is happening in Zuul microservice. Our next target will be to send the request via this Zuul API gateway. We don't want to send the request directly to other microservices. If we are going to call the currency exchange service, it should go from the Zuul API gateway. We are going to test our currency exchange service. So our currency exchange service is hosted on port 8000. So we'll convert from USD to INR. We are not calling our service through any gateway. We are directly calling our service. So let me refresh it, and if you come to the STS and see the logs, you will be seeing that we have the logs generated for currency exchange service application. And as you know, we are hitting this service directly. If you want to hit this service through Zuul API gateway, you need to form this URL in such a manner that it should directly hit the Zuul API gateway. So currently we have this URL, but if we want to hit this through the Zuul API gateway, what we need to do, let's form the URL and HTTP localhost, the port where Zuul API gateway is hosted. Let us check that. So the Zuul API gateway is hosted on port 8765. After that, the application name will come, the application name, and after that the URI will come. So currently the application name for currency exchange service, we will go to STS and find out what is the application name for this currency exchange service. In the currency exchange service, we'll copy the name and paste it here, and in the URI, what service we are calling, that URI will be coming. So the URI for this currency exchange is this one. So now let's copy this URL and let's go to hit it through browser, open a new tab and just paste this and click on enter. So now you can see that we are getting the response which is same to same as the currency exchange service, but this time we are hitting it through Zuul API gateway. And let's see the logs of Zuul API gateway. So I've selected Zuul API gateway and you can see that our logs are getting printed. We will check what is there in the log. If it's not clear, let me clear the log and hit the service once again. And let's come here and see what is coming in the Zuul API gateway logs. So we are getting that our request URL, whatever we have given, that is coming here, but that is in this format, that is not showing in the format which we wanted. So let's see why we are getting like that. So to get the request in the correct format, you need to add request.get request URI, then you will be able to see the request correctly. So now let's go and hit the service once again. Click on the refresh button and let's go to the logs of Zuul API gateway. So now we are seeing the logs of Zuul API gateway, and if you come to the right here, you can see that the request URL is getting printed currency exchange service, currency exchange USD to INR. So here we saw that our request is not going directly to the microservice we are calling. It's getting intercepted by the Zuul API gateway, and we are making use of the logging filter to log the request which is currently under execution through the Zuul API gateway. So let's review what we have done. We are calling the currency exchange service through this Zuul API gateway directly. We are not calling this application directly. Now what we want to call the currency calculation service which is internally talking through this currency exchange service, but it is directly calling. But now what we don't want to call it directly. We want to call it through this Zuul API gateway. So whenever a user comes in and hits a request for currency calculation service, it should go to Zuul API gateway and then call the currency exchange service. So let's see how we can implement that in our STS. So the process is same here. All our applications are interacting with this Eureka naming server. So whenever any service is calling this currency calculation service, it is getting the instance of this currency exchange service. So we will tell our application to pick the instance of Zuul API gateway, and Zuul API gateway will call the currency exchange service. First of all, let's see how we are getting the output from the currency calculation service. So let's go to our browser and open a new request, localhost 8100, that is where currency conversion service is hosted, and let's see the output here. So this is what we are calling directly, and internally it is making the use of currency exchange service to get this data. So as of now, if you see here, you will not get anything in the logs for Zuul API gateway. So what we are going to do, we will open this currency calculation service, and in the controller here, let us hit with the Feign client first. Obviously we'll get the same output here as well. Now we want to hit this through Zuul API gateway. So how we can do that? So let's copy this URI and keep it in our notepad. So this is a call to the currency conversion microservice, and internally it will be calling this currency exchange microservice. So how we are making the call from currency calculation service to currency exchange service through a currency exchange proxy. So if you see here, the Feign client name we have given the currency exchange service. In place of this, we don't want to call this service directly. We want to call the Zuul API gateway whenever it is intercepted. So what we will do, we'll just make a copy of this one so that we have a history of what we are doing, and let me paste it here. Let me comment this line. And here let us give the service name of Zuul API gateway. So the Zuul API gateway service name, we'll take it from the application properties of Zuul API gateway. We'll copy this thing and we will paste it in here. So whenever this service is intercepted, it will go through Netflix Zuul API gateway server. If you compare the URLs here, whatever we have written in the notepad, whenever it will call the Zuul API gateway, it will take the service name and the URL. So it has made a call to the Zuul API gateway. We have got the local host, but we have not got the service name here. So the service name, we have to append this in our URL here. So our URL will be something like this. Let's save this application and wait for the changes to pick up, and let's hit our service again. Let me clear the console of Zuul API gateway. So now let us go to hit the service, this currency conversion service, and see what happens. Let's open the Zuul API gateway server logs, and we can see that the request is getting intercepted and the request currently is this one. So we saw that whenever we are making a call to currency calculation service, the internal call which is going to currency exchange service is through Zuul API gateway. Let us do one more thing. We will keep the history of this one. I'll just keep it enter. I will delete this one because it was our earlier URL. Let me comment out this line, and our current URL is this one. Let's do one more thing here. Whenever a end user wants to hit this service, it should go through Zuul API gateway. So that's not a big deal. We have this URL here. We will copy this here. After that, we will give the application name. So the application name for the currency converter service, let's copy it from our currency calculation service. Let's copy it from our application properties, the currency calculation service, the application name. After that, what will come? The URI will come. So the URI is this one, and let's copy the whole URI. Let me clear the console of Zuul API gateway, and let's open a new browser. And let's go to the Zuul API gateway logs. Now if you see here that there are two requests. The first request is for currency calculation service, that is used by the currency calculation service, and internally it is making a call to the currency exchange service. So our both the requests are intercepted by Zuul API gateway, and that's what we are seeing in the logs here. So this is all about the Zuul API gateway. You have got a hands-on how to use the Zuul API gateway. So this completes the session here. One more thing I wanted to tell here, guys. I have not been uploading my videos for some time. That's because I have this new website which we launched a month back, and we want all your support for this website. The website is still under development as of 29 December 2020. You can come and visit whenever you want, and the things that we offer here is the tutorials on Spring, Java, Python, then the videos, all our videos, you will get it in the videos section. Any new update about the videos, you will get it here. So with that, we will see you in the next video on distributed tracing. So till then, bye bye, thank you. So in this video, we are going to learn all about Zipkin distributed tracing server. So the question arises that why do we need a Zipkin distributed tracing server? So let's look at the problem first. We have this many microservices where each of the microservices is talking to one another. We have Eureka naming server, the Zuul API gateway, the currency calculation service, the exchange service, and these are one way or the other talking to each other. In the real time, there can be hundreds of applications. Here it is only 4. So what happens when a user makes a request and the request is not fulfilled? The application breaks there. So how do you find out where your application broke? What was the problem? Because we have so many different microservices, we cannot go to all the microservices one by one to find out where is the issue. So we have to implement a centralized logging where we can trace each of the requests and find out which request is failing. So here we are going to use a Spring Cloud Sleuth, which will give a unique request ID to each of the requests. And that is, whenever a user makes any request, a unique request number is assigned to that request as it travels from currency calculation service to Zuul API gateway to exchange service. It will be having a common ID which will be used to trace, and that will be assigned by the Spring Cloud Sleuth that we will be implementing in this video. So this Spring Cloud Sleuth will be assigning this request ID, and all the logs from all of these microservices will be stored in a RabbitMQ, and we will be sending that logs to a Zipkin distributed tracing server. So I hope it will be clear why we need a Zipkin distributed server, so that we can trace each of the requests individually and we can have a common logging for our common goals. So let's start the implementation. So as you can see here that we have different applications and we have to identify which all applications we want to implement Spring Cloud Sleuth. We would be implementing it in Netflix Zuul API Gateway, the currency exchange service and the currency calculation service. So how do we implement Spring Cloud Sleuth? So there is a dependency that we need to add in each of our application where we want to implement that. So the dependency that we have to use is Spring Cloud Starter Sleuth. Let's copy this and add it in our Zuul API Gateway pom.xml. We can go and add it here. Control A, Control I. That will format our pom.xml. Yes, save it and it will download the dependency for Sleuth. Now the other thing that we have to do in order to implement Sleuth in our application is we have to create a bean in our main application. Let's go to the main application, add this piece of code where we will be using the sampler and we will create a new bean. Let me import the bean dependency, the sampler that is coming from our Sleuth Brave sampler, okay, and return. This is the default sampler. That means that we want to implement the Sleuth in all of the requests that is coming through this Zuul API gateway. So we have to implement this default sampler dot always sample. So let's save it. The dependency that got important, you can see it here. And we have to implement the same thing in our currency exchange service pom.xml. We will add the dependency. In the dependency section, we will go and add the dependency. Similarly, we will do it in the currency calculation service. We will paste it here, Spring Cloud Sleuth, and we will also copy the bean from here and paste it in our main application of currency calculation and currency exchange. Let's save it, import the dependencies. That is still downloading the dependency, and we will do the same thing in currency exchange service application. Create the bean here. It's already imported because the dependency is downloaded. Okay, so the dependencies are downloaded and we have added in all the three applications. So one more thing we have noticed in our applications that we don't have much of the logs to see the changes that we have just made. So what we'll do, we are going to add some loggers using Slf4j logging. So how do you implement Slf4j logging? So let's go and implement Slf4j logging in our application. First of all, we will do it for currency exchange service. Go to the controller and below the class you have to write this statement logger, and this logger will be your Slf4j logger. You have to import the Slf4j, import the logger factory from Slf4j, and the class name you have to give your current class name. So this is the logging that we are going to implement, and now we can go and use this logger anywhere in our application. So let me print this exchange value here, logger.info, and whatever you want to give it here. I will give this exchange value. This is the placeholder, and this value will come inside this placeholder. Let me organize the imports. So there are some errors. This is not our errors. This is a problem of Eclipse or STS. Sometimes it behaves like that. So let me refresh the project and the errors are gone. Now we have this logger in place. Let's go and implement logger in our currency calculation service as well. Go to the controller, and here before returning we want to print this calculated amount. So first of all, you have to give the logger statement in the beginning. You have to change the class name here, then use this variable to print your logger statement. We already have a logger in our Netflix Zuul API gateway. Now to test this logging feature, we will start our applications in an organized manner. So first of all, we will start our Eureka naming server. Okay, so our naming service is started. Now we will start our Netflix Zuul API gateway server. And after that we can start any of it. We will start our currency calculation and currency exchange, and we will go to Eureka naming server port number 8761. So this is our Eureka naming server. It is showing that our Zuul API gateway is already registered with naming server. Now let's wait for the other two applications to start up. All our applications are up. Let's go to naming server and refresh it. So you can see these services are up. There are 3 instances of this one is up. That was not required. Anyway, we'll stop the other two to reduce the load on my laptop. Okay. Now we'll go and test our currency exchange service. So the currency exchange, we will hit it through Zuul API gateway. Let's go to hit our currency calculation service. Click on enter. So Histrix read timeout Zuul exception. After starting the Eureka naming server, we have to wait for a minute or two. It will make everything ready for us. So after refreshing, I can get this value now. Let's go to the logs and check what's happening here. Let me copy these statements and check in our editor. Let me clear the logs in here so that it won't be confusing for you. So this is a currency calculation service. Let me copy this, check it in our notepad. So this is the log of currency exchange service. Let me go to the log of Netflix Zuul API gateway, and we will copy everything from here and keep it in our notepad. What I wanted to show here is that there is a unique ID generated by Spring Cloud Sleuth, and that is across all the microservices. So if you see here, if I'm clicking on this number here, that is the unique ID, and you can see the same unique ID here. The one you are seeing it here is the previous request. Let me delete all that. Okay, so there is one unique ID here, and the same is through here as well in the Netflix Zuul API gateway. So this unique ID generated by Spring Cloud Sleuth is helping us to understand where our request is flowing through, which all microservices it is hitting, what are the output from there. If you see here, the exchange value that we gave here is coming in this one, and the request URL that is in our Zuul API gateway, that is also getting printed. So if any problem occurs in our any of the microservices, we will be having the unique ID, and through that we can search that where the problem has occurred. For now, you see that our logs are coming into different windows of Spring Tool Suite. In the next video, we will implement the centralized logging so that all our logs will be coming at one place. So in the last session, we implemented the Spring Cloud Sleuth, which was able to generate a unique ID for each of our requests, and we were able to find out where all the request is flowing through, what are all the components involved. But there was only one problem that was associated with it, and that is we have to go to individual microservice to trace the logs. So that was the problem. Now in this video, we will be implementing a centralized logging system. All the logs from different microservices will be coming at one place, and it will be logged in an organized manner so that it will be very easy to understand for anybody. Okay, so there are so many providers of centralized logging. If you see, there is Kibana, there is a Splunk, and other providers are there where you can perform Elasticsearch and filter out the logs that you want based on different kind of string search. Now the question comes how we can implement that. We will implement that using Zipkin distributed tracing server, which will provide us a UI. But how do we push all our logs to Zipkin distributed tracing server? So we will use something called MQ. that is RabbitMQ, the messaging queue. We will put all our messages in the queue, and the Zipkin will be listening to this RabbitMQ. It will get all the logs and put it in an organized manner, and after that we'll be able to see the logs in one place. Basically, the Zipkin uses a database to store all the logs in one place, but our requirement is just to understand the concept. So we will be using H2 database, the in-memory database. Now in this video we are going to start with the RabbitMQ installation. So all the links I have given down in the description. First of all, select the operating system that you are. Here I am using a 64-bit Windows system. So I will click on this link here, and Rabbit is an interdependent service. You need to have something called Erlang downloaded in your system before using RabbitMQ. Otherwise it will not work. See here the dependencies. RabbitMQ requires a 64-bit supported version of Erlang for Windows to be installed, and you can obtain this Erlang from this website. Meanwhile, if you go to the RabbitMQ website, what are all the supported versions that is given here? If you are going to use a RabbitMQ with a version 3.8.1, you will have to install Erlang of version between 22.3 to 23.8. We'll be installing the latest version of Erlang from the website. So this is the official website of Erlang, and we will be going and installing this 23.0. Click on this link here, the 64-bit version of Windows, and we will click on start download. And meanwhile, go to the RabbitMQ website and click on the get started. After that you will see this link, download plus installation. Click on that. Click on this link here, and you come down here, you will see this RabbitMQ server. Click on this download link, and it will start downloading this exe file as well. So both our things are getting downloaded. So now our both the softwares are downloaded. Now we will install each of it one by one. First of all, we will install the Erlang. It's a pretty simple installation. Just click on next button. Keep everything to default. Okay, so the installation is complete for Erlang. Click on the close button. Now we'll install the RabbitMQ. Installation of both our Erlang and RabbitMQ is completed. How we can check if it is installed correctly? Click on, just type localhost colon the default port number for RabbitMQ. Default port is 15672. Click on enter. If you are getting this page, that means that your RabbitMQ is not started yet. Click on the start button, and after typing this command, your RabbitMQ will start. I will give this command in the description. Now let's click on the refresh button here. Now you will get this console. So here you need to provide guest and password as guest. That's a default username and password for RabbitMQ. So we have successfully installed our RabbitMQ in our local system. Now we have downloaded the RabbitMQ. The next step will be to download the Zipkin distributed tracing server jar file. So there is jar file that you have to download from the official website of Zipkins. Just go to the browser of your choice and type in Zipkin. Quick start. So this will take you to the Zipkin official website from where you can download the jar. After coming to Zipkin quick start, you will be getting so many methods to download the jar file. One of the method is by using the Docker. If you have already installed in your system, you can use this command to get the jar file. If you have a Java 8 or higher version installed in your system, the easiest way you can get the jar file by clicking on this link. If you want to use the source code of the Zipkin, then you can go to git bash and clone it using this command. After that you can build the project by clean install command of mapping, and then you can start your jar file. But what we will do, we will just take the jar file from this link here. If you have Windows 8 or higher installed, the quickest way to get started is to fetch the latest release as a self-contained executable jar. When I click on this link, it will start downloading a jar file that will be around 60 MB. So our jar file is downloaded. I will keep it and let's go to the location where it is downloaded. So it's here. I will keep that in a folder where it is easily accessible to me. Okay, so now we have got the jar file and how we will run this jar file. So from here, let's go to the command prompt by typing in cmd in the address bar, and from here let's type java-jar and the jar file name .jar. Click on enter. So this will just run the jar file and it will start the Zipkins. Once you get this, after that you have to go to a new browser and type in localhost colon 9411 Zipkin. Click on enter and you will see something like this. So currently we don't have anything in the logs. So as of now what we have done, we have just started this Zipkin distributed tracing server, but we have not connected this RabbitMQ to these Zipkins. In order to get the logs, we have to make this as a listener because it will connect to this RabbitMQ and it will get the messages from the queue. So how we can connect this RabbitMQ? There is a command that we have to run. First of all, we have to cancel this because we have simply started the Zipkin distributed tracing server, but we have not connected the MQ. Now we are going to connect the MQ. So for connecting the MQ, you have to give this command. If you are on Mac, you don't have to give this set. If you are on Windows, then you have to give this command set rabbit URI equals to amqp :/ localhost java -jar and the jar file name. This jar file name we have to give, and then we have to press on enter. What we have done is for this jar file we have set the RabbitMQ path as this one. So this Zipkin will be listening to this queue. For Zipkins to listen to RabbitMQ, we have to set a command that rabbit URI we have to set it to amqp : localhost. So this will set up a rabbit URI, and after that we have to run the command java-jar the jar file name. This time the Zipkin server will start and it will listen to this URI. So it is started on port 9411. Let's go to port 9411 and you will not find anything in the trace here because we have configured the RabbitMQ and we have configured the Zipkins to listen to RabbitMQ, but we have not configured our applications to send the messages to this RabbitMQ. So that's why we are not getting anything in the logs. So the next step will be to connect our microservices with the RabbitMQ. And the microservices to connect with RabbitMQ is currency calculation service, the currency exchange service, and the Zuul API gateway server. So in order to connect that with the RabbitMQ, we need to have some dependencies form.xml. And let's go to add those dependencies one by one. So we have opened the form.xml for currency service. So one of the dependencies add will be for Spring Cloud Sleuth Zipkin. Cloud Zipkin is basically to generate the logs in the format that Zipkin distributed tracing server is able to understand. And the next dependency is Spring Cloud bus AMQP. So AMQP is a protocol that we use for MQ for communicating or sending the messages. Save this. So Cloud starter bus AMQP, and we will also add this dependency in our currency exchange service form, and similarly we will add that in Zuul API gateway so that message from all these will be to tracing server. So the progress. Now one more thing to notice here is that we have given these two dependencies and our Spring version here is 2.3.2. So this set of dependencies that we are using with the Zipkin, actually that might not even work with this version of the Spring, because we are using a version of a Spring that is less than 2.1, then these dependencies will be useful. But if you are using a higher version than 2.1, then these dependencies will not be useful and your Zipkin distributed tracing server will not even work. So what we have to do, we have to make one change here. Spring boot starter Zipkin. This is the new dependency that Spring has changed. Spring Cloud Starter Zipkin. And the second dependency here is Spring Rabbit. So let's save it, and this dependency is not taking because this is coming from AMQP. These are the weird ways, but what to do? Once Spring is changing, whatever the command Spring is giving, we have to follow that, otherwise our application won't work. So these dependencies we have to change it in all the three projects, the Zuul API gateway as well, and in currency calculation service as well we have to change it. So we have made the changes and the dependencies are getting downloaded. So now we have done most of our changes and it's time to test our application now. So one by one we will be going to start all our applications. So we'll go to the boot dashboard, and first of all we will launch the Netflix Eureka name server, and we will wait for it to start. So you should start your services in a correct order. After that you can start the Zuul API gateway server, and then you can start the currency exchange service. Then you can start the currency exchange service, and simultaneously you can start the currency calculation service as well. So now all our four services are up, and our Zipkin distributed tracing server is also up, and the MQ is also running in the background. Let's make sure that everything whatever we have said is up and running. Eureka, let's refresh it. So the Eureka is running with all these three services. Now our MQ is running in the background. The Zipkin, so our Zipkin is also up and running. So this is our Revit management console. Now let's test one of our services. Let me click on the refresh button. So it's timeout. This will usually come because we have just started the Eureka naming server. Will take some time to register all the services. So now it's giving a correct response. So now if you come here and see that in the last 5 minutes in the Zipkin we have got these two logs here, where the trace ID will be this one. It is intercepted by Zuul API gateway server, where we have got logs for this trace ID. Let's hit it once again and query blank query. I've hit it again, got the log few seconds ago, and this is the trace ID and where all the request has gone through. That is also populated here. Our main task was to handle the centralized logging. We have done it using Zipkin distributed tree. Have a look at all of this and figure out what all the things do. So our goal has been established. We are able to send the logs to Zipkin server. So this was our main goal. So thanks for watching. We will see you in next video where we will discuss about fault tolerance and Histrix.